Good morning, friends. We'll start again RT numericals. I already discussed when transmit 100%, the density is 0, 10%. It is just like this. So when transmit 0.011%, that is density 0.95, 3.958. That's what you have to find out. If something is given like that, 100 divided by that, the transmission energy or transmission potence, something like that. They'll write. Okay, 160 kV, 70 centimeter FFD, and density 2 behind 15 mm thickness. In 12 mm thickness, how much? From the graph exposure chart for structure XD7, I already told you you have to take this chart from the question books. The last pages about. You can find this, no problem. For 12 mm exposure should be. Okay, this is exposure chart for structure XD7. They will provide this, so no problem. It is not here, so just I don't have it, but still you can find. From 12 mm exposure should be 5 mm minute. For 15 mm exposure should be 10 mm minute. The difference is 5. And it is 160 kilovolt. The X-ray chart, that is 160 kilowatt and then 70 centimeter of FD. So you can easily find N2 density 2. 0.02 mm lead screen. So log 10 of 10 by 5 equal to 0.301. The density 2 graph film characteristic curve, LRE 2.2. For density under 15, 2.2 plus 0.3. This is the milliampere difference, and so N by 5. The difference you get is 0.3. The exposure time is 0.01 second, 100 quanta transmitted through penetrometer body, and through hole 102 quanta. So it is 100 background, 2 signal, noise 10, SN ratio 0.2. So this type of question will come, not this type of question may or may not come. Just to understand the basics, they will not ask too much because they have 135 questions. Some questions are lengthy, maybe total 5. So 1 second. This is different question. So background 10,000 and 8 second. This is not for this one. This is slightly different than signal is 200. Okay. Signal is 200. 1 second. So they had missed the point 1 second. 1000. Then 1 second is 10,000. 4 second 4,000. 6 second. And then they found SN ratio 5.065. So when pipe greater than 5, so 8 second is required exposure time. Is the hole, the only hole visible is it must be 4T, because if 2 there is 2T, but if single hole you can see 4T, so it is 0.5 inch, so T equal to 0.0125. Sensitivity is 100 by X, 2.8 given, so T by H, and they find X is 0.63 inch. The 192 source strength 2.60 BQ. This terabecquerel is 10 to the power 12, 2.6, 2 into 2.6 into 10 to the power 12 becquerel. And that is only they have you have to understand, that's all. D1 equal to 3 millimeter. Shielding is 60 mm thick. Dose is 7.5 micro sievert per hour. So you have to find HBL and all. 1 curie is 3.7 into 10 to the power 10 becquerel. So HBL is 0.693 divided by mu. Mu is given linear attention coefficient 0.0462. So HBL is 15 and it's 60 by 15. Shielding is 60. So N is 4. 1 MR is 10 millisievert. So dose is 0.75. That is microsievert. 1 MR. 1 MR is 10 microsievert. So the dose is 0.75 MR. Then they will just this. See, there is one here, 2.6 into 10 to the power 12. Where you don't understand, here 0.75. You have to remember. That's all. Then dose rate is SS into RHM, and so strength into RHM into 1000 divided by 2 to the power n d square. That's all. You have to put the values and you find D. D is 57.4 meter. Because this D is meter and all others are no, nothing is there. You have to remember this units, otherwise you make mistake. Okay. Graininess and contrast ABCD. The radiography produced using energy 400 kV. So what will happen? Voltage change to 500 kV. So kV increase, contrast increase. Contrast decrease, sorry. kV increase, contrast decrease, and graininess increase. So it is D. kV increase means the light, the bulb, if you consider as a bulb, so it will be powerful. That's all. Then your contrast will decrease. Contrast is the difference between the two thickness. You cannot understand because it will just submerge the area. So 500 mR per hour equal to 0.51 meter, 2 foot. That is the 2 foot. And it 8.13 meter, 32 foot. So I1D, just I1 by I2 equal to D2 by D1 whole square. That's all. You have to find I2. That's why D1 by D2 square into I1. Either this way you can do, or this way you think. So it will decrease only. Try to decrease only so you can find it. It is approximately 2 mR per hour. Either way is okay. Of the following source factors, which has the greatest effect on exposure time? Source size. No. Available activity of the source, Curie. Because it is the absorption coefficient, no. Half-life, no. The primary problem with source of cobalt in excess of 1000 Curie. Self-absorption. Half-life not problem, RHM, no. Beta radiation, no. If half-life cobalt 60, 5.3 years, RHM is 1.3. What is RHM per Curie value in 10.6 years? So it remains same. RHM remains same after any number of years. That is no problem. You cannot change it. Which of the following energies is the film on sharpness likely to be least? So on sharpness will be least UG. Or you can say contrast is good. That's a 250 kV. Which of the following artifacts could not be caused by improper film processing? radiation fogging, oxidation fog, air belts, ret- reticulation, all artifacts caused by improper film processing. Radiation fogging is maybe your cassette is broken or something like that, or somehow light pass. A series of well-obtained ruptures caused by high localized stress which develop cast, as casting cools would be identified as hot tears. If a photon doesn't experience an energy shift upon being scattered by an atom, the process is spoken. Spoken if as being coherent is the phenomenon of Rayleigh scattering process, coherent scattering. Is often referred to as one of the following effects. The HVL of the steel for cobalt 60, 1 inch. Source side steel plate, 3 inch. Opposite side is 64 Ranjan per hour. N is 3. So R by H at opposite side 64 divided by 2 means this side, one side is 64 Ranjan per hour, the other side 2 to the power 3 divided, that is 8 Ranjan per hour. Okay, we'll stop here.